So we were talking about the work of Tycho Brahe, and he did fantastic work, major observations of the sky, the best naked eye observations ever. The problem is that in order to do these fantastic observations, that's not the sole thing you have to do. You have to do a lot of mathematical analysis. So we need a computer. Now, up until just a few decades ago, a computer was actually a job title for someone who computed. And so he would go to a local university and hire a computer and bring him out to the island of Ven, and then they would compute for him for a while, and they usually got tired of him because he wasn't very nice to them. And they'd leave, and he'd go hire another computer. And so one of the computers that he hired was a fellow by the name of Johannes Kepler. Now, Kepler actually was hired by Tycho Brahe as a computer. When he was, Kepler was originally at the university studying to be a Lutheran minister. So in those days, seminary students would take a tremendous amount of math and science. The idea would be that the science would teach them about God's creation, and the math was considered good discipline for the mind. And so he was very good at the mathematics, and so he was hired by Tycho Brahe and started working for him. Well, about that time, the king of Denmark died, the king that had been a good friend or helper to Tycho. Well, the new king was not quite as enamored and took away the guy's island. And so Tycho then sort of ended up going from place to place throughout Europe, trying to get a new sponsor. Tycho, unfortunately, was still kind of a drunkard. And so at one of these events in which there was a prince there, that was drinking very heavily. Well, if the prince is in the room, nobody leaves the room until the prince does. That's standard etiquette. So he ended up not going to the bathroom when he should have gone to the bathroom, and ended up dying of, they argue whether it was a ruptured bladder or a bladder infection. At any rate, he died very painfully over the next week or so. And so Tycho Brahe died, but there was no one really to take over his work except for Johannes Kepler. So Kepler took over. Now, Tycho was a spectacular observational astronomer. Kepler had very poor eyesight, so he never could reproduce the work. Not only that, but he did not have the spectacular naked eye observatory that Tycho had originally, and so he never could really keep up with Tycho's works. And so what Kepler did was he started a new way of doing astronomy, and that is mathematical astronomy. He sat down and did mathematical analysis of Tycho's work. There's many astronomers today that rather than doing their actual observations themselves, they do mathematical analysis of other people's observations. And so Johannes Kepler was like one of the first to do that sort of thing. So Kepler was working through all the mathematics, and he realized that there was no way that it made sense to have all the planets go around the sun and the sun go around the earth. So he knew about Copernicus's work, went back to that. He knew about Bruno's work, and decided that maybe Bruno was right. Not that there's people on other worlds, but that maybe what's happening is that the stars are so far away that that parallax was too small to measure. So he again went back to the idea that stars are suns. And so this was a new idea. Not a new idea, but back to that. And so the sun's the center of the universe, and the planets go around. The problem was that this was a good idea, except that the math didn't quite work perfectly. But he was analyzing in great detail a lot of the work and all the observations that Tycho Brahe had done. And in doing so, he was looking at the orbit of a comet that Tycho had observed. And that comet, the only way of describing that orbit would be if it's so elliptical, it's actually crossing the orbits of several planets. Now, this was a huge step forward, because up until this moment, all astronomers, all the way back to the ancients, had assumed that all the planets moved in perfectly circular orbits. A circle was considered the most perfect of shapes, and so surely what's going on in the heavens would be this perfect shape. And so that was the idea that everybody had. Copernicus had that idea. And it didn't quite match. That's why he invented one epicycle per orbit, so to make that shape a little bit less round. Well, by analyzing the path of this comet, it clearly was not a circle. And so this led him to realize that maybe if the orbits of the planets were not perfect circles, that would explain things. Maybe it's some other shape. Now, there's a lot of non-circular shapes that are out there. And so he decided to try to analyze this. And so, interestingly enough, he came across the idea, from what I've read, while drinking a stein of beer. Okay, and so, well, this is actually a cup of water, but at any rate, you know, if you look down into it, then what happens is that it is round. It's circle. But he tilted it to drink out of it, and he looked in there and said, wait a minute, that's not a circle, it's an oval shape. Well, oval is mathematically something, but he realized that mathematically this is not just an oval, it's a very special subtype of oval. Something that in mathematics we call an ellipse. And so an ellipse has certain mathematical description for it. And so he realizes that it's a subset of that circle shape, so it's still a pretty perfect shape. And so he comes to the realization that planets move in elliptical orbits. Likewise, the comet moved in a technically elliptical orbit. And so this changed the understanding of orbits. So he comes up with 3 laws of planetary motion to describe this. And so that was the idea they came up with, these 3 laws of motion. We call them Kepler's laws of planetary motion. And so we want to go into that now. So Kepler's first law of motion is that the planet orbits the sun in an ellipse, and the sun's at one focus of the ellipse. Second law of motion is if you draw a line joining the sun and the planet, as the planet moves in a period of time, that line sweeps out equal intervals of area in equal time. And the third law of motion is that the square of the sidereal period of a planet is proportional to the cube, the semi-major axis of the orbit. Okay, now that's technical wording. That's what your book says. What does that mean? It means the planets move in ellipses. Okay, so that means that the planets move in an ellipse. And now, mathematically, the way you define an ellipse is you define 2 points, and you call each point the focus. 2 of them will be foci. Okay, and so that defines an ellipse. The way you define an ellipse mathematically is if you have a spot on the ellipse, and you take the distance between each focus, that the sum or the adding of those 2 distances is always the same. So that's actually one way that you can actually draw an ellipse. If you wanted to draw an ellipse, is you can take a string and make a loop of string, put 2 little nails down, and then just draw around to see if you can match out of a shape. The other thing, the speeding up and slowing down. So you have an ellipse here. The sun is at one of those focal points. What's at the other focal point? Nothing. Kepler's laws say the sun's at one focus point, there is nothing at the other focus point. So the ellipse is simply an ellipse around that one focal point. Now, if you were to draw a line, if the planet is here, you draw a line to it. After a while, the planet is there. Draw a line to it. And so it sweeps out this pie-shaped area. When the planet's in a different part of an ellipse, gravity is not as strong, and so it doesn't go as far. And so it moves less of a distance, and it sweeps out a long, skinny, pizza type shape. Well, what Kepler says is those two wedges have the same area. The only way they have the same area, because one of them is shorter than the other, is if it's fatter, meaning that in the same length of time, the planet has to move farther. So when the planet is close to the sun, it moves fast, and when it is far from the sun, it moves slow. So that is what that means there in terms of Kepler's laws. The third thing he says is that p squared equals a cubed. P is the sidereal period, and a is half of that long distance across the orbit. Okay. So what we're going to do, we stated Kepler's laws. Well, now what I want to do is explain them, because I can say them, but it makes more sense if they're explained. Okay, so I tried to say them in technical terms, then I said them in more general terms. Now I'm going to explain them.